Hello again! In the last video, we discussed our approach to building the HUD and we laid some of the groundwork for it. In this video, we're actually going to finish that work and have a functioning HUD at the end. So let's go ahead and get started. The first thing we need to do is actually construct or build the pieces that will populate the HUD, the widgets. In this case, it's going to be the widget to show the power bar. So let's do that in the editor. So let's go to our blueprints folder. Let's right click, and I like to create a new folder for UI to put all the UI widgets in. You don't have to, but this is the way I like to do it. Then right click and go to user interface, widget blueprint, and I'm going to call this my blueprint underscore widget power. All right, now we just double click on that to open it. And then here it is maximized, and if you are not familiar with UMG, I'm going to let you take a break here and go research this in some other videos and then come back. So what we're going to need to do is add a progress bar to it for our power bar. So we're just going to grab the progress bar, drag it in. Then we need to, you can see it's anchored in the top left, let's anchor it down in the bottom middle. Then we need to set its position. So we're going to put it at 0. We'll lift it up from the bottom of the screen by about -100. Make it 600 units wide, and offset it to the left by 0.5, so it's halfway on the left and right. Okay, now we need to figure out what we're going to put in this progress bar. Down here is progress, and you see the percent. If you grab this and drag left and right, you can see it going up and down. This is what it's going to look like. And we know it's going to go from 0 to the amount of power needed to win the game, or power to win. And we're going to track that as a percentage. The way we'll calculate it is to take the current power and divide by the power to win. So we're going to do that and populate this variable through a binding. So click bind, create binding, and here's where we're going to set up the function that will go and fetch us the data and do the calculations. So I'm going to spread these two endpoints out, alt click to disconnect, and so the first thing we need to do is go ahead and grab the power to win, and we get that from the game mode. So let's get our game mode. Then we need to cast that to our game mode type. And then from there, we'll grab power to win, get power to win. Okay, that's all we need to do with that. Then we need to, let's go ahead and connect that. So we're going to do that. And then the next step is we need to get the player, and from there we get the player's, the current power, rather. So the way we're going to do that is we're going to get the owning player pawn, because our value is stored in the pawn. So grab the owning player pawn. That's going to work right here. You can see it on the client. We're going to cast that to our character type, NMP game character. There we go. And then once we have that, we're going to get current power. There we go. And now we will connect these up. So after we do that, we're going to go off and get the player pawn, cast it to our character type, and we're going to get the current power. And now we did divide current power by power to win. So just drag off of there and say divide. It's a float division. Divide by that, and plug the return value into the percentage. And then we output here. There we go. Okay, so this is essentially what we want to do. However, there is a problem, and I hope that you have already recognized this and are questioning when I'm going to solve it. The problem is we are getting the power to win from the game mode. And as we've discussed multiple times, the game mode only exists on the server. So this is not going to work. What are we going to do? We cannot get the power to win on the clients through the game mode because the game mode's not there. So we need to find a solution. Well, lucky for us, Epic's already thought of this. The Unreal Engine already has something for this, and it's called the GameState. And what the GameState does is it helps track unsurprisingly, the state of the game. And so we typically put things in the GameState that are usually transient. That is, they're not persistent, they're not some aspect of the game logic that sticks around, but they show things that are relevant during gameplay. So maybe the current power to win that we calculate, maybe the team score, or other things. So we're going to use the game state for this because the game state is replicated to all of the clients and available. So our game mode can stuff data into the game state and have that available on all of the clients. So we're going to need to do some code and some refactoring. So for now, we're going to set this aside while we go and replace this part of the functionality. So I'm going to go ahead and save this, and then we're just going to bail out of that. And we'll circle back to that a little bit later. But for now, we need to get into our C++ and create our game state. So down in our folder, we'll right-click and go New C++ Class, and scroll down until we find game state right there. And we click Next, and we need to give it a name. So Network Multiplayer Game State. I really did a poor job of setting the name of this game. Create that class. Okay, so that is going to be created for us, and then the editor is going to recompile code, and then we'll pop over to Visual Studio, and we'll start doing the work that we need to do there. Okay, so how are we going to do this? Well, there's a couple things we can do. Over here in Visual Studio, we know that we have the game mode, and in the game mode we're setting the power to win. And we need that to be replicated out to clients. So one way would be to put the power to win in the game state instead of the game mode. The problem with that is, as I said, game state is typically a bunch of transient variables just used to replicate out to clients information about the current state of the game as gameplay progresses. So putting game configuring values there doesn't really make a whole lot of sense given that use case. So we need something else. Well, in our case, let's take a look at the way we derive the power to win. Here's where we have power to win in the CPP file, and what we did was we made a calculated value by using initial power and a multiplier. So here's what we're going to do. We're going to treat the power to win as a transient value that is a calculated or derived value from those two inputs. So instead of hard coding one of those inputs, we're going to make this configurable. And that will be the piece that we store in the game mode. We're going to call that our power to win multiplier. And then we're going to move the actual power to win, which is now a derived or calculated value that happens at runtime. We're going to move that into our game state because now it's kind of more of a transient thing. So let's rename this power to win as the power to win multiplier. And we're going to make this just like our decay rate. Edit, defaults only. It's blueprint read write. It's in the category power to win. And we'll go ahead and add the blueprint protected meta keyword to that. So now we have the power to win multiplier. And so we can also go up here to where we have get power to win, and we can get rid of this. We could call it get power to win multiplier if we wanted to. I don't think we're going to need this, but we'll go ahead and leave it in there just in case. So get power to win multiplier. And let's go into our game mode and change that implementation before I forget. So get power to win multiplier, and it actually returns the power to win multiplier now. Okay, and now we know about it as a configurable value just like our decay rate. So we're going to set it here in the constructor, set a base value for the power multiplier, and this is power to win multiplier equals, and we'll just put it to the 1.25f, same value. Alright, and so now this is going to have some red squigglies for a minute, but now instead of multiplying it times this hard-coded value, we're going to put in our power to win multiplier. Okay, great. Now then, we need to set up our game state class to actually house the new power to win variable. Alright, so we need to do that in our game state. So go over here to our game state, and here it's there's not much boilerplate, so we're going to need to add our stuff. So let's start with our constructor. So it is a nmp game state, thusly, and we need to store our current or our power to win now. So that is a float, power to win. And you'll notice I'm just leaving this in the public section. I'm doing that on purpose because we don't really need to protect this, we can access it directly. So it'll be fine. We're going to make this a U property, and it is replicated. And it's going to be blueprint read only, and it's in the category of power. Okay, and this is to track the power level required to win the game. All right, perfect. So now we have our power to win stored here, and it's just a public variable for now, which is fine. So let's go over to our implementation. We got to write our constructor. So we'll go in here and put our NMP game state, a NMP game state. And there's really not much to put in there right now, so we'll just leave that empty. And so now we need to take a moment to think about our situation. Are we finished with the game state? Recall that we created a replicated variable. What do we have to do? Ah, yes. We have to add our scaffolding code for networking. So where is a networked object? We can just go ahead and grab that. We can copy it from our pickup base class, for instance. Here, get lifetime replicated properties. Copy that. Back over to our game state. And just throw it under our constructor. Paste. And then I'm going to try our little trick, control period enter. See if it'll write that signature in the CPP file for me. Well, that may have been a mistake. Sometimes IntelliSense takes longer than it would take for me to actually type it. Hey, it worked. Great. Okay, so I'm going to bail out of that, switch over here to my implementation, and now our standard process, call the superversion, get lifetime replicated props, pass in the out lifetime props value, and then we need to declare our do rep lifetime, put in the name of our class. Let's copy paste that, and the name of the variable, which is power to win. Whoops. Okay, that didn't work for me. Okay, and we have the little red squiggly lines because we still need to include the network header. So net/Unreal network.h. All right. Now we have all of that set up. The red squiggly lines will go away whenever IntelliSense catches up. And I think that is all we need to do in the state. So now we have a power to win variable in the game state. So let's go back over to our game mode so we can put it right here and grab it. But of course, we need to get a handle to our game state. And the way we're going to do that is the same way we did with the world. We're going to actually go ahead and assume this is going to work. So we want to get our ANMP game state. We'll call it my game state. And we are going to use, you see the base class, the game mode base class already has a variable called game state. And if we look at it, you'll notice in the tooltip pop up there that this is a game state value, but it is a pointer to the base class game state, but we need to cast it. So what we need to do is cast to the ANMP game state type the variable that exists, the game state. All right, and one other problem is we get all the red squigglies. Scroll up. We need to include the game state here. Include NMP game state header. All right. Now we have access to this class to actually use it. We're going to grab a pointer to it, and we'll go ahead and check that. Check the my game state pointer. Perfect. And now what we're going to do is say, hey, my game state power to win, and set that, calculate it based on the initial power multiplied times our power multiplier. And so now we can go into the editor and make edits to the power to win multiplier, and then we'd be able to control sort of more directly the difficulty of the game. Perfect. Now we've got all of that set. Let's go ahead and do a compile. All right, so we're going to do a compile there, and that should be everything that we need in order to switch back over to the editor and get to work on actually building the HUD, finish building the HUD rather. Okay, so that compiled, everything looks good. So let's go ahead and switch gears back to the editor. And here we are going to go back in our UI and let's open up our widget again and go to our power bar. We need to hit the little magnifying glass and that'll take us here to the function. And now we know we can get rid of this because we're not using the game mode. We are instead going to get it from the game state. So right click game state, get the game state, and we need to cast it to our game state type. And then as that, we're going to get the power to win. Perfect. And we get the power to win from there. And connect all these. Whoa. Connect that here. And now our power to win goes into here. Excellent. Now, whenever we want to update the percentage, we get from the game state, we're going to go ahead and grab the power to win, and then we get from the pawn, the current power, divide current power by power to win, and there's our output. Perfect. Let's compile. And now you'll notice that we've got a few notes here. And if we look at them, what does it say? Info, the execution path doesn't end in a return node. So that's telling us that this, if the cast fails, we never arrive at the return node. So we never get an output value. And that's kind of a problem. So we need to go ahead and deal with that. Well, there's in fact a situation where maybe that doesn't happen, but there could be another problem because now we're looking at a replicated value. And what happens if the value has not been replicated yet? The default value of power to win in the game state will be 0. What happens if we go over here and take current power and divide by 0? That's not a very good operation to do. You don't want to divide by 0. That doesn't really work. So we're going to need to solve these two problems. So in the first case, we need to deal with the case where the power to win is 0, is not greater than 0. It's a 0 value. So let's put in I'm going to hold B and left click to get a branch. And what we're going to do is check if this is greater than float, greater than float. If it is greater than 0, connect that up. And now we're going to wire that into this line. Okay, so now if the value is greater than 0, then we will go ahead and use it and do the division. And that'll be fine. That's perfectly reasonable. But it's not okay if it's not 0, if it's not greater than 0. So what happens if it's false? Well, this is the same case. What we need to do is have these multiple execution paths all still yield some kind of valid return value. Well, how are we going to do that? Here's what we're going to do. We are going to take this value and promote it to a variable. We're going to call that variable, because this is outputting the percent to win. So this is percent toward victory, percent toward winning. Sure, the percent toward winning. That is the value that we're going to have that goes in the return here. And now, rather than pointing the result of our output into that node directly, what we're going to do is we're going to actually output it to a set value for the percent to win. So I'm going to grab the percent to win, alt drag it out here. Now I got a set. So I'm going to say, okay, let's take the division and set the percent to win. All right? And now we're just going to wire that in here and here. There we go. So now the result of the division will set the value for us, and then we'll go on to the returning. But what happens in the case of, like, for instance, if the value is 0? Well, we still need to set the percent to win, but we want to set it to something else. We'll just set it directly to 0 so that the progress bar is completely empty in those cases. So again, alt drag this out, and the percent to winning is 0. The default value there, we're going to put it to 0. So if the value of power to win is not greater than 0, then we're going to go ahead and set this value to 0 directly and return from the function. All right? That's going to be our approach. Similarly, if this cast fails, we're going to just set the value to 0 and return from the function. That way we're always getting a valid output from the function. And lastly, here, we're going to do the same thing. So in any of the cases where things go awry somehow, we will just set the output to 0 so the progress bar will be empty and then return from the function. So we're always producing valid output. Now let's go ahead and clean this up. I'm going to right click and put in a reroute node. I need to reroute these because they're kind of overlapping all over the place. So we'll do that. And then we'll do the same thing. We'll do another one of those. Reroute node for the false. Drag the false up there. There we go. And, oh, whoops, wait a minute. I grabbed the wrong one. This goes here. It's supposed to be the failure case. Wow, I almost introduced a bug, didn't I? Okay, so the fail case goes up here, goes into the set and bails out. And same with this one. Okay, good, good, good. All right, I think that is all we need to do. So let's give it a compile. It all works, and all those blue notes went away. So now we can just do a quick review. Whenever we call this, we're going to get from the game state our power to win. If the power to win is greater than 0, then we go ahead and get from the character the current power, divide current power by power to win, and set that, and we're done. If anything goes wrong, we set it to 0 directly, and exit, and we're done. Awesome. Okay, that is all we need to do. Let's go ahead and save that. Bail out. And why don't we just go ahead and hit play and see what happens. Let's test it out. The editor just crashed. Perfect. Okay, let me go ahead and close that. And I'm going to restart. I'll restart. 1 second. Let me open the editor again. Bear with me 1 minute while I reopen the editor. Apparently it really didn't want me to redo that, to do that test. Okay, so let's save everything. Open this back up, just take a quick look at our power bar. Check this. Everything looks fine. We did compile and save. Good. Alright, and we've compiled. Oh, let's compile code. Good. And let's run the test. And it crashed again. So I have set something incorrect. Game mode line 42. The assert failed. Oh, it crashed on purpose. Game mode line 42. Okay, sweet. That means the handy assert asserted for us because our game state is probably not valid yet. So let's take a look. We'll just go into Visual Studio and switch over to our game mode. Set line 42. 42, and indeed, my game state didn't work. Oh, I know what happened. I didn't actually set the game state type in the constructor. Yes, so you remember that we set the type of pawn class, we set the type of HUD class, we need to set the type of GameState class, and I forgot to do that, and so that's why we got this this problem. Okay, so let me just take care of that. So what we need to do is, right in here, the base class for the game mode actually has a GameState class, which is what we want, and we're going to assign that to our game state type. So our NMP game state static class. We grab the static class function there, and okay. So now we've actually set this. So set the type of game state used in the game. Okay, so that's what I forgot to do. All right, so that catastrophic crash actually helped us out if I would have read the log the first time. The crash actually helped us because it prevented us from doing something crazy because it just immediately crashed the game because something was horribly wrong. All right, now let's go ahead and compile. And so now we're actually setting that. And again, the game state, we could have done that in the editor, but we're doing it in C++. So, okay, now if we hit play, It starts up, but you'll notice there's no power bar at the bottom, even though everything seems to be working. Why is that? Well, let's exit out, and it is because, as we've discussed previously, the HUD is the container and driver for this stuff, and we did not tell the HUD to take this widget and add it to our viewport. So we need to do that. So let's take a look at our HUD, double click on that, and that'll open up for us. Oh, not the class. I'm really discombobulated apparently. Go to our blueprints, and this is our game HUD. Open that. There we go. We're going to need the full blueprint editor. I'm going to drag it up here. And what we need to do is actually say, okay, now HUD, turn on these elements, turn on these UI widgets. Okay? It actually needs to take those blueprints for the UI widgets and create an instance of those, or that one blueprint in this case, and then add it to our viewport. So we're going to do that in event begin play. Let's drag off of here and say we're going to create a widget. So it's going to create the widget for us. And let me zoom in there. There we go. The class is going to be our BP widget power. And then we are going to add to viewport. Add to viewport. There we go. And we pass in that as a target. There we go. So I'm just going to throw a comment around this. Set up the initial HUD widgets. HUD power widget. There we go. Let's compile and save. That's pretty much all we need to do. So on the client, because you can see the little icon here, this is happening on the client. So on the client, I'm on the client, my HUD starts, and I'm going to create an instance of the power widget and add it to my viewport. Great. Let's exit from there, save everything, and hit play. Lo and behold, now we have a power bar, and power is draining. And if I grab some power, my power goes up, and now I've hit the top of the bar. So that would mean I've hit the level of power necessary to win the game, but of course we haven't actually added the functionality for changing the state of the game or for actually winning it. And we're going to turn our attention towards those things in future videos, but for now we actually have a HUD. So now we've finished both the base implementation of the HUD. We're going to actually add some message text later, but we've got the base implementation of the HUD, and we've got our graphics and visuals all done for this project. So in the next video, we are going to start working on play states. So we'll start setting up the various states that the game could possibly be in. All right, so enjoy our HUD, and I will see you guys in the next video.